Hello and welcome to our Week 5 session in Biostatistics. Today, we're diving into a fundamental concept that underpins much of what we do in this field, an introduction to probability. So, let's start with the most basic question. What is probability? Simply put, probability is a measure of how likely an event is to occur. It's the language we use to talk about chance. In biostatistics, this is incredibly important because it allows us to quantify the uncertainty that is inherent in all research outcomes. Probabilities are expressed as values ranging from 0 to 1. A probability of 0 means the event is impossible, while a probability of 1 means it is absolutely certain to happen. To work with probability, we need to understand a few key terms. First is the sample space, which is the set of all possible outcomes of an experiment. An event is any subset of that sample space, basically any outcome or group of outcomes we are interested in. We can break this down further. A simple event is an event with just a single outcome, while a compound event is one that includes multiple outcomes. Let's make this concrete with a simple example, rolling a standard six-sided die. The sample space, or all possible outcomes, is the set of numbers 1, 2, 3, 4, 5, 6. Now, what's the probability of rolling a 4? Since rolling a 4 is a single outcome, its probability is 1 out of 6. What about the probability of rolling an even number? This is a compound event because it includes the outcomes 2, 4, and 6. There are 3 favorable outcomes out of 6 possible, so the probability is 3 to 6, which simplifies to 0.5. This brings us to the basic formula for calculating probability. The probability of an event, written as P event, is the number of favorable outcomes divided by the total number of possible outcomes. For instance, if we're drawing a single card from a standard 52-card deck, what is the probability of drawing a heart? There are 13 hearts in the deck, so the probability is 13 divided by 52, which equals 0.25. But what happens when the theoretical probability is unknown? In many real-world and experimental settings, we can't just calculate it on paper. In these cases, we estimate probability by using experiments and observing the relative frequency of an event. The formula is that the probability of an event is approximately equal to the number of times the event occurs divided by the total number of trials. This concept of relative frequency is directly related to the law of large numbers. This law states that as you repeat an experiment a large number of times, the relative frequency of an event will get closer and closer to the true theoretical probability. For example, if you flip a coin 10 times, you might get 7 heads. But if you flip it 10,000 times, you'll get very close to 5,000 heads, or a relative frequency of 0.5. So how do we apply this in our field? Probability is everywhere in biostatistics. We use it to estimate the risk of a person developing a disease. It's crucial for evaluating the effectiveness of new treatments in clinical trials. We also use it to interpret the results of diagnostic tests, for instance, determining the probability that a person has a disease given a positive test result. And fundamentally, it allows us to predict outcomes and make inferences about a whole population based on sample data. Now it's your turn to apply these concepts. I'd like you to work with a partner on a short activity. First, define the sample space for flipping 2 coins simultaneously. Second, list all the events where you get at least 1 head. Third, calculate the probability of that event, getting at least 1 head. And finally, take a moment to discuss with your partner how the law of large numbers might apply to this coin flipping experiment. I'll give you a few minutes to work on this, and then we'll discuss it as a group.